Hello, today we are going to be talking about radicals. We're going to be doing a lot with them this unit. As we get into special right triangles, we're going to do a lot with square roots, and we're going to want to make sure that we have exact answers, so we're going to need to be pros at simplifying radicals. First off, you need to make sure that you know what a perfect square is. A perfect square, what makes a number a perfect square, is that when you square root the number, you don't get a decimal, or you get a whole number. You get a whole number. So examples of perfect squares would be like 4. When you square root 4, you get 2. You're thinking what number times itself is 4. 9 is a perfect square because the square root of 9 is 3. 16 is a perfect square. Square root of 16 is 4. 25, 36, 49, 64, 81, 100, etc. These are all examples of perfect squares. So when you square root the number, you get a whole number, no decimals or anything like that. Radical rules. No perfect squares can be left under the radical. No negatives can be under the radical. And no radicals in the denominator if there is a fraction. All right, so we're going to utilize factor trees a lot. We've already kind of done some stuff with those earlier this year. So remember, when you're doing factor trees, you're just breaking it down to prime numbers. So you got to think about, okay, what multiplies to be 75? So you could do like 3 times 25. 25 can break down to 5 times 5. You circle the pairs. So I have a pair of 5s. The pairs go on the outside. For each pair, you write the number down once. And then any leftovers that don't have a pair, you write them down once under the radical. So pairs go outside, leftovers stay under the radical. So the answer would be 5 root 3. Notice it says exact answer, which means no decimals. So like square root of 90, you would do something like 9 times 10. 9 breaks down to 3 times 3. 10 breaks down to 2 times 5. Circle the pairs. Pairs are going to go on the outside. For each pair, you write the number down once. And then the leftovers, the 2 and the 5, go under. If you have more than one leftover under the radical, those get multiplied together. 2 times 5 is 10, so you end up with 3 root 10. Square root of 27, same idea. 9 times 3 is 27. 9 breaks down to 3 times 3. You have a pair of 3's and a leftover 3. The pairs go on the outside. The leftover stays under. And so you get 3 root 3 for your answer. All right, 405. If you aren't, you're too confident with 405 just because it's kind of a big number, what you can do is you can always just do 405 divided by 2, 405 divided by 3. If it ends with like a 5 or a 0, it's probably going to be divisible by 5 or 10. Since this ends in a 5, we know that 5 goes into it. And if you just do 405 divided by 5, you're going to get 81. All right, 5 you can't do anything with. 81, you can break it down to 9 times 9. Now, what you can do is, if you notice, we've got a pair of 9's here. So if you want to stop and just circle the pair of 9's, you can do that. You don't have to break it down to the primes. If you come across a pair of non-prime numbers, you can totally do that. And so what you'd end up with is a pair of 9's on the outside and the leftover 5 underneath. All right, if you didn't do that and you broke it down to 3 times 3 for each of the 9's, you'd end up with 2 3's on the outside and the 5 on the inside. You'd still end up with 9 root 5. But if you come across a pair earlier, do that so that you don't have to go and keep breaking it down if you don't want to. 24, you got 8 times 3. You can do 4 times 2. 2 times 2. So we've got a pair of 2's, a leftover 2 and a leftover 3. So the pair goes on the outside. The leftovers, the 2 and the 3, stay under. When you have more than one leftover, they get multiplied. So you get 2 root 6. All right, we're going to skip number 6. Let's go to multiplying. Innies and outies. All right, when multiplying radicals, you multiply what is inside the radical by what is inside the radical, and what is outside the radical by what is outside the radical. Innies and outies don't mix. Be sure to simplify. So let me show you what I mean. All right, you've got like a 2 here that's outside the radical, and you've got a 3 here that's outside the radical. Those get multiplied together, and then the numbers under the radical, those get multiplied together. So you got to make sure you keep them separate. Don't ever multiply a number that's not under a radical with a number that is under a radical. So the 2 and the 3 are both not. You multiply them, you get 6. 5 times 6, you get 30. And then you want to make sure that you simplify. So if you can break down the 30 and get some perfect squares out, you can do that. 30 is not going to break down. We don't have any pairs. 3 times 10, 10 breaks down to 2 times 5. There's no pairs here. So the answer is just going to be 6 root 30. All right, but if you could pull out any perfect squares and simplify, do so. All right, for like the next one, you got 4 and 5 are both outside the radical. 6 and 2 are both under, so you can multiply those. You get 12. Break down the 12, you'll have 4 times 3. 4 breaks down to 2 times 2. So we do have a pair of 2's that can be brought out in front. So the 2 is going to join the 20 out in front, and the 3, the leftover, stays under. So you end up with 40 root 3 for your answer. The next one, technically the second radical, there's a 1 in front, so you could do 11 times 1, which is 11. Square root of 3 times square root of 3 is the square root of 9. You can do a factor tree, but the square root of 9, that's a perfect square. Square root of 9 is 3. Once you square root the 9, you don't need a square root symbol over the 3 anymore. It's 11 times 3, which is 33. All right, square root of 9 is just 3. For this one, number 10, same idea. Multiply the outside numbers together, you get 15. 12 and 6, you get 72. And then you can break down the 72. You could do 36 times 2. 36 breaks down to 6 times 6. Since I already have a pair, I'm just going to stop there and put the pair of 6's out in front with the 15. And then my leftover 2 is going to stay under the radical. And then you multiply and you're going to get 90 root 2 for your answer. And then this guy, same idea. 9 times 5, you have 45. 4 times 8, you have 32. You can break down the 32 to 16 times 2. 16 breaks down to 4 times 4. Since I already have a pair, I'm just going to circle it. And the 4 is going to go out in front with the 45. And the leftover 2 is going to stay under. And then you just multiply 45 times 4. And you're going to end up with 180 root 2. Right. So that's kind of how that one works. Let's see, on to the next page, adding radicals. You probably did this a little bit last year in algebra. When adding or subtracting radicals, you need to have common radicals. Right. Then you can just simply add or subtract the coefficients. So, for example, when you have something like 3x plus 5x plus 2y plus 4y, you can only combine like terms, all right, common variables. So, like 3x and 5x could be added together, that's 8x, and then you can combine the y's, 4 and 2. Remember, you just add or subtract the coefficients. 4 and 2, you get 6y. Same idea with smiley faces. You got 3 smileys and 5 smileys, that makes 8 smileys. And then you have 2 frownies plus another 4 frownies. That makes a total of 6 frowny faces. And then when we get to radicals, same idea. You're looking for common radicals. So like these ones both have a root 2. Once you have that, combine the coefficients. Just the 3 and the 5 get added. You have 8 root 2. So you have 3 roots of 2 plus 5 more gives you 8 roots of 2. And then you combine the root 7's. 2 plus 4, you'll get 6 root 7. You just combine the coefficients. So something like this one, it doesn't look like anything combines. However, you can simplify some of them a little bit. So like square root of 75, you could do 25 times 3. 25 breaks down to 5 times 5. So you have a pair of 5's and a leftover 3. We still have a 5 root 3 here. I'm going to simplify the root 27 as well. You got 9 times 3. 9 breaks down to 3 times 3. So you got a pair of 3's and a leftover 3. And then you can combine these together. They all have root 3, so you just combine the coefficients. 5 plus 5 is 10. 10 minus 3 is 7. Root 3. For this guy, same idea. You can break down the 8 a little bit to 4 times 2. You have a pair of 2's that can be brought out with the 4. So 4 times 2, which is 8 root 2. The 50, you can do 25 times 2. 25 breaks down to 5 times 5. So the 5 goes out in front with the 3, which makes 15. And there's a minus there. And the leftover 2. And then 12, you can break that down to 4 times 3. So you got a pair of 2's joining the 7. 7 times 2 is 14, and you still have a leftover 3. After this, you can only combine the first two because they are the ones that have the root 2. This one has a root 3, which makes it different. So you just combine 8 minus 15, that's negative 7 root 2. And then you still have 14 root 3. That just kind of gets added on to the end. All right, now rationalizing the denominator. Since radicals cannot be left in the denominator, we have to rationalize the denominator. To do so, we multiply the top and the bottom by the simplified radical that is in the denominator. This will turn the denominator into a rational number. All right. So what happens is we're going to multiply it by itself, because what happens is if you do something like square root of 5 times square root of 5, that's the square root of 25, which is 5. All right, so if you have something like square root of 10 times square root of 10, that's square root of 100, which is going to equal 10. Any radical times itself will equal the number under the radical. Square root of 1,000 times square root of 1,000 will equal 1,000. Square root of 2 times square root of 2 will equal 2. So when we do something like number 16, we want to get rid of the radical in the denominator. So we're going to multiply the top and the bottom by the square root of 6. You get root 6 on the top. Square root of 6 times square root of 6 is just 6. Now you cannot reduce those 6's and say, oh, that equals 1, because one's under a radical and one's not. You can only simplify if they're both under a radical or both not under a radical. So that's as far as we can go with that problem. For this one, we can multiply the top and bottom by square root of 2. Now, on the bottom, square root of 2 times square root of 2 is just 2. On the bottom, 6 and 2 cannot be multiplied. All right, it's not going to be 12 because one's under a radical and one of them's not. Technically, this is like a 1 root 2, so you can multiply the 6 and the 1, giving you 6, and then you have root 2 still. Now, the 6 and the 2 underneath it are both not under a radical, so you can reduce those. 6 divided by 2 is 3, square root of 2. 18, you can multiply the top and bottom by square root of 3. Again, this is under a radical, the 3 is under the radical, the other 3 is not, so you can't combine them to make 9, but you can have 3 root 3, and on the bottom, square root of 3 times square root of 3 is 3. Now the 3 on the top and the 3 on the bottom can be reduced. 3 divided by 3 is 1, root 3. All right, for this one, we're going to multiply by root 3, and you have 7 root 3 on top. Root 3 times root 3 is 3, and then there's still a 2 on the bottom. 2 and 3 make 6, and then we have 7 root 3 on top. If you could reduce 7 over 6, you would do so, but you can't. Now 21, you could multiply top and bottom by square root of 12. I would recommend you could do it that way, or you could simplify it first. It's up to you how you want to do that. If you want to simplify it first, you can. You could break it down to 4 times 3 and 2 times 2. So really the bottom is 2 root 3. And then you can multiply the top and bottom by root 3. So it's up to you if you want to simplify it first or simplify it after you multiply. On the bottom, root 3 times root 3 is 3. You still have the 2 here. On the top, you can't multiply the 8 and the 3 together to make 24 because one's under a radical and one's not. And on the bottom, you still have 6, and you have 8 root 3 on top. You can divide the 8 and the 6 to reduce them both by 2, and you get 4/3. All right, and that's all you can do. You cannot cancel out the 3's because one's under a radical and one is not. For this one, square root of 9 over square root of 50. All right. When you have a big old square root like that, you can break it down to square root of 9 over square root of 50 like this. I would simplify a little bit, like square root of 9, that's a perfect square, that's 3. Square root of 50, you could break that down to 25 times 2. You have a pair of 5's and a leftover 2, so you'd have 5 root 2 on the bottom. Now you can get rid of the radical on the bottom by multiplying. You get 3 root 2 on top. On the bottom, root 2 times root 2 is 2. And then you still have the 5. So you end up with 3 root 2 over 10. And that would be your answer there. So if you need to divide it up into 2 smaller radicals, you can always do that. So now you have kind of a general idea of how to rationalize the denominator, and now what you're going to do numbers 10 to 33 in the Unit 10 packet. This will give you some extra